Multicast routing. So before we mentioned that we had a way to send things unicast, which was one-to-one, or we can do multicast, which was one-to-many. And so what we want to do here is we want to be able to send our traffic to a Class D IP address, which is known as a multicast group. Our main goal here is to send traffic only to the devices that want to receive the traffic and not to everybody else. That way we can eliminate some of the traffic on the network. There's two primary protocols that we use with multicast. The first one is the IGMP and the second is PIM. IGMP is Internet Group Management Protocol. It's a protocol used by clients and routers to let the routers know which interfaces have multicast receivers on them and which clients want to join the multicast group. PIM, on the other hand, is used from router-to-router communication for multicast, and it allows routing of multicast traffic between different multicast-enabled routers. Multicast routing protocol forms our multicast distribution trees, and I'll show you how that works in a few minutes here. So first we have our Internet Group Management Protocol. And so in this case we have PC2 at the bottom who wants to join the multicast group. So what he'll do is he'll send a join message to his default gateway, which is this router. Now when this router receives traffic from the multicast source, he'll send it directly to PC2 and not to PC1 or 3 because they're not members of this group. Now if PC1 or PC3 had sent a join message as well, we would see that the single source from the multicast source would come into the router and be sent to both those receivers. But in this case, only PC2 wanted to receive it, so only PC2 will get it. With PIM, this is where our router-to-router communication occurs. We have two different modes that PIM can operate in. One is our dense mode and one is our sparse mode. With dense mode, what we're going to do is do a periodic flood and prune behavior to form an optimal distribution tree. And I'll show you some pictures of that as well. This is going to cause a negative performance impact, though, on the network because you're flooding it with so much traffic and then reducing back to what is required, which is what we do in that prune. Generally, in most modern networks, we're going to use PIM sparse mode, or PIM-SM. What it initially does is it creates a shared distribution tree, but it may not be the best shared distribution tree. And then over time, it's going to create the optimal distribution tree and switch over to the shortest path tree to create the most optimal environment. So what that looks like with dense mode, when we flood, is you can see here, all of the routers are getting the information from the multicast source, even though there's only one receiver there at the bottom. And so the information is getting to and from the receiver from that multicast source through all these different routers. By doing this, it is getting at the most optimal method, which in this case would be this direct path here because it has the least amount of routers, if we're assuming we're using RIP. And so as the information is going, really the receiver is going to receive it first up this left side of the tree, and all these other routers are getting bothered with this information even though they don't need to. So what happens is this entire network is flooded, all this network is getting all this information, and unnecessary bandwidth is being used. Once we go from the flood mode to the prune mode, it realizes that this left tree is the shortest path, and it will prune off all of the excess by sending a prune message. And at this point, the routers send out the multicast traffic in that initial flood. The traffic that's not needed is now pruned off, and they're going to be removed from the distribution tree. And that will leave us with the optimal route of going down that left side only. So you can see how this floods it with a lot of information, prunes off the excess routers, and now gives us our optimal tree. The big problem we have with this flood and prune is that it happens about every 3 minutes. And so this can start causing excessive performance issues on your network by having lots of flooding and then pruning on your network. So what we use nowadays is more the sparse mode. And what sparse mode does is we use a shared distribution tree. Notice that the multicast source here is talking to the receiver in whatever router it could find first, which happened to be this route, which is not the most optimal because I have to go through 4 routers instead of just going 3. Now, as it creates this path, information is starting to be exchanged. This first router is called the rendezvous point, and that's where it's going to start by sending the information there and then getting it down to the last router. After that information starts flowing, the last hop router, which is the one closest to the receiver, will go, hey, I know of a better way. And they'll send a message that then creates a shortest path, and we'll get a switchover to that optimal route. So it may not be the fastest to start with, but it doesn't give you all that flood of traffic. And so that's why sparse mode helps us out. So this gives us a suboptimal path at first, but once that last hop router receives the information from the first packet, it can then find the optimal distribution and create this best unicast routing table for them to be able to talk. This eliminates all the pruning that happened before and allows us just to go straight to a shortest path. And that is the basics of our multicast routing.